Hello, Internet! We are again in the series of explainable artificial intelligence, and today we are checking out the feature attribution on YouTube. So, can you learn something from YouTube if you put in feature attribution? And this is exactly what I have done. And the first video YouTube algorithm recommends to me as a video from 3 years ago from MLconf. The second is one from spring 2021. That has been updated or uploaded 13 days ago, so quite recently. And the third video is from AAAI 2022. Do feature attribution methods correctly attribute features from 1 month ago, accompanying a paper? So these are the 3 videos. Let's have a look at it. And I will do this for you and tell you, can you learn from YouTube about feature attribution? Other videos you can see, oh yeah, this is a nice one by TensorFlow, Introduction to Explainable AI. This is nice, 6 months ago. It's a very good introduction. Others, I don't know. Hey, this looks interesting by PayPal. PyData, a PyData conference in Tel Aviv by PayPal. SHAP values for machine learning explainability. Maybe we have a look at this one. And then people also watched. So 4 videos. I will watch this video for you and tell you what I think about this video if you can learn about feature attribution for explainable AI. And on we go. And so we are here with our first video by Stanford from spring 2021. And as you can see, it was uploaded on January 7th, 2022, and it is about feature attribution by Professor Christopher Potts. And this is a very nice video, but you have to be somehow familiar with feature attribution. As you will see, he has a short introduction on motivation. Then he goes on with the Captum library. I already have a video on the Captum library if you want to check it out. In a little bit more details, he gives you the different methodologies you can apply. And then we jump into more or less the axioms by the original paper by the gradient input. And of course it is interesting, but I would recommend have a look at the original paper or at my video doing input gradients or the integrated gradients, because I will explain it in a little bit more detail than he does. But it is a nice mathematical introduction to feature attribution. Now, then he has something very nice, and this is pictured here. Let's stop for a second. He has a PyTorch implementation with pure Python. And then under 3, you can see he uses Captum, the Captum software package, the library, where there are quite a few methodologies already encoded for you. So you just have from Captum attribution import X integrated gradient methodology, and it will do all the thing for you. But if you want to learn about the methodology, he gives you here the pure PyTorch Python code, so you really understand what's going on. And he also uses a TensorFlow code later on. So he gives you both the PyTorch coding and a little bit of a TensorFlow implementation. So you should have a knowledge of both PyTorch and TensorFlow, and of course Python. It's very nice. He has some introduction, a little bit of mathematics, and then he shows you directly the code implementation. And what is also very nice, he has a Jupyter notebook with it. I leave you the code in the remarks of this video, and as you can see here, more or less he has for his presentation here input X gradient, selective example, simple feed-forward classifier, bag of words classifier, why bag of words fail, and then he tries a BERT example, trying to explain why BERT comes up with a sentiment classifier, for example. So again, all the code he shows you, you have here for you. You download the Jupyter notebook and you can code immediately. Go on. You have here the example code, the simple feed-forward classifier, the bag of word classifier, and then of course the BERT example, where he gives you the code he uses, and of course then the predicted label and the attribution label and the attribution score. and the word important. So very nice, you have an accompanying Jupyter notebook with it. Then the lesson, let's call it, goes on. He gives you some formulas we know about these integrated gradients, and tells you a little bit about theory, more about theory. He gives you the official mathematical formula for integrated gradients, and as you can see here, he adapted it from the TensorFlow integrated gradients tutorial. Very nicely done. I have a specific video on the TensorFlow implementation where I go with you through the coding in TensorFlow of this formula. I leave a link for you to my video in the upper right-hand corner. And then he goes on. Sensitivity, yes, the axioms. He gives you a feed-forward example. This is straightforward. Yes. And then he comes to the famous bird example. And then what he does the code implementation. I just showed you the notebook for this. You run through all of this code. And then this is the result. This is the output we are looking for. You have a sentence. This is illuminating, full stop, and indicating which word of this sentence, this is illuminating, has an attribution score of 2 with a predicted label of 0.93. You can see here that it is the positive in green, illuminating, and a little bit here, the exclamation mark. So illuminating is positive. Interesting, this is a little bit more on the negative side, but you can see this is what you get out of this example. So a very nice video for more advanced user, familiar with the mathematical notation, familiar with PyTorch programming, TensorFlow implementation, Jupyter notebooks, and he provides you a beautiful Jupyter notebook so you can really follow his presentation. You can explain it, you can code it yourself, you can play around with the code, you can modify a little bit, you can see how it works. So first video, yes, nice, Stanford University, of course. What else would you expect? Okay, and now to the top video Google recommends if I input feature attribution. And as you can see, this is a video from 2018, November 14th, San Francisco, machine learning conference from a presenter from Google Brain. And this was the real surprise, because this video is not at all about feature attribution. But this video is fascinating. You know the simple reason why? Because you have to think about it. There are some excellent presentation. It guides you through a topic beyond feature attribution that is fascinating to follow, even for half an hour. So let's jump right into it. And you have a presenter that is doing a great job. Even for me, and I'm new, I just have some weeks with feature attribution, with explainable AI methodologies, but she's doing a great job starting from the very basic, going on, explaining everything to you, building a meta model with some quality function, some abstraction that is beautiful, going on to some saliency maps where she explains to you, wait a second, here we are. If you have a trained machine learning model, a neural network model, and you want to identify here, for example, the ATM cash machine, how does the picture know that this is a picture of an ATM machine and not just of a human or a trolley or whatsoever? And she explains this with a saliency maps very nicely. We've got saliency maps to measure the importance of each pixel, even if you do not know the coding of a saliency map. She gives you a very nice theoretical explanation where she shows you, like here, for example, that the little wheels here in the background behind the man, as you can see here, they're very bright, so they are very important for the classification task. And even if you look at the human standing in front of the ATM machine, you see that the human too is highlighted. And then she simply asks, okay, which feature is it? Is it the little wheel? Is it the man standing in front of an ATM? will the ATM only be recognized as a ATM machine if you have a person standing in front of it. So very nice presentation of the idea of a saliency map. And then she asks, okay, there's again this human subjective judgment that she has. And then she says, okay, we have a local understanding of the data, the task, the model, whatsoever, the neural network model. What happens if we change it? And this is a very nice approach because you really have to think about it. And she gives you an example where she says, okay, we have an image, and then we do a beautiful deep neural network, and then we have a saliency map, which pixels here in this picture are important for the identification that this is a bird. And say, okay, and then we make an experiment and we just make some random weights. We destroy our model in the last layer. We just do some randomization, some absolute nonsense. And what comes out of it, and you will not believe it, because, come on, you get a picture that's also featuring this bird. And they say, what the heck is happening here? And this is such a nice presentation because it's not just based on formula, but it gives you the way of thinking about a problem. And this is something amazing. And I now understand why this video from 2018 is the top video that Google, that YouTube algorithm recommends to you for feature attribution. Also, this video is not at all about feature attribution. It is going one step or even two steps beyond feature attribution. So what they do, they show you, they do some testing, and wow, the result is really strange because somehow you need to define a new method. And of course, they present you a new method and they say, okay, we do not want to have a local understanding, but a global understanding. And yeah, they go on with it. I don't want to give away all the clues, but what they have is a post-training explanation. Of course, you have a deep neural network, and then you have the saliency map, and then you make, and then they present a new model to make explanations using the way humans think. And they show it to you, and they tell you, again, here you see this. Does the concept human really matter for this prediction of the neural network, that this is an ATM? Or does this little wheel here in the background is the important concept? And they abstract this and they say, hey, let's make this kind of a meta feature and this kind of a meta feature and examine the importance of this. And she presents the way of thinking about this. And this is the very nice part. For example, here, if you have two pictures of a doctor, how you would classify in a deep neural network the doctorness? How much does a deep neural network that was trained on this has a gender bias? Is it because it is a woman that it is higher probability to be a doctor? Or to be a man, does it increase the doctorness feature, the concept of being a doctor? How important is the feature of gender, for example, to the probability of a correct identification of, example, to be a doctor, the doctorness? And it's so interesting because she gives you quite a lot of ideas and you have to think about it, and not the way that you think about it when you code something, because there's such a deep domain-specific knowledge she presents. So, I like this presentation. I recommend this presentation to you. Although it goes beyond feature attribution, but it starts beautifully and you really are able to follow her through. And even the methodology she represents to you, where she just separates some sets with some linear classifier and just some orthogonal vector, where she says, okay, the further away I go, I can now have a simple vector presentation. I can define a vector space with my different concept activation vector, as she calls it. And the further away, the more significant this particular concept is for the identification. of the object in my picture. And she goes on, and she, of course, does a lot of evaluation so that the model is solid. That's great. But this is also a nice sanity check, and I like this. Look at this. It is so simple. You have a picture with a cab, a taxi, as you would call it in Europe. And then she puts also, so you have a picture, and in the picture you have a alphanumeric description, and she just writes cab. And now she says, okay, and now we train the model on this, a deep neural network. And then I want to know, does the model identifying this as a picture of a cab looks at the word, at the caption concept, or does it look at the image concept? Which of the two will become the dominant force for the artificial intelligence system, for the neural network, to say, hey, this is a cab. This is a picture of a cab. And she goes through and she explains very nicely, if you add some noise, what happens. And it is great. And she gives you a real interesting example from a fire truck, for example, where you also have a geographical bias. Because sometimes if you train a network to identify a fire truck, maybe it also has some probability that there's a red fire and rescue written in red. And in some other countries, you might have a complete different color. You might have a different color of the car. Maybe the car is in red and the writing is in blue or yellow, or I don't know. Or if here in Australia, that you have a yellow fire truck with the writing in red. And she shows you, well, you have everywhere also a geographical bias, because in every different country, in every different continent, you might have different conventions. So when you train a network, you have to be so careful to transfer this model to a different culture, to a different region, where you have some other values that are important, or some other conventions you have to take care of. So this is a video I highly recommend if you want to think about it. Your brain will become, I don't know, will be turbocharged. I learned a lot about beyond feature attribution. So fascinating that this is the top YouTube video. Yes, I agree. It is not at all about feature attribution, but it shows you the way to think about the concept of feature attribution, of explainable AI. And it gives you some really deep insight, some domain knowledge, how scientists or coders think about the problem, what they have to care about, how they can validate it, where are the limitations of the model, how they find out to discover these borderlines, where they have to investigate further. Very, very good video. Have a look at this. I leave you, of course, a link to all 3 videos in the description of this video. And now to our 3rd video from our top 3. This is now what YouTube algorithms recommended to me if I look for feature attribution. And this is a recent paper, a recent video accompanying a preprint on arXiv. It is uploaded December 2021. As you hear me now, I'm here in end of January 2022. So less than 2 months, you have 43 views. But the nice thing is, this is a video accompanying a preprint on arXiv. And also, you will find, if we look at the publication, that they have a GitHub repository with the code. So this is a very positive feature about this. The video itself is a little bit different, I would say, and let's summarize it. They have here investigated 3 different parts in their question, and the first is on image, the second is on text, and the third is on rational. And if you ask me, I would say, well, with image, it depends a lot of the methodology you use. The second on text is, well, more or less a non-favorable answer. Do feature attribution work? And the third with rational is also a non-favorable answer. So if I would say at the end of 2021, MIT and Microsoft conclude that more or less these things are not working, I was interested to read the paper. And I just, because I don't want to give a wrong impression, so I checked, and I'll leave you the link of this preprint from archive. And they tell you feature attribution are popular methods in interpretable machine learning, in, or if you will call, explainable AI. They have little systematic evaluation, complicated in particular, but a lack of ground truth attribution. And they propose a dataset modification procedure to induce such ground truths. And they identify several deficiencies and add some new perspective. So let's jump for the visual to the saliency maps. Let's just quote them here. We simulated a common scenario where the model seemingly achieves superhuman performance, so better than a human, on some hard image classification task, only for us to later find out that it exploits some image artifacts, which are accidentally leaked in during the data collection process. And if you look at the final wording, they say, arguably one of the most important applications of model explanation is to detect any usage of spurious correlations, but our result casts doubt on this capability from various aspects. We recommend that before analyzing the actual model, developers should first train models that are guaranteed, well, this is stiff, to use certain known features and dry run the planned interpretability methods on them to make sure that these features are indeed highlighted. So, seems like a lot of work still ahead of the visual team. Now, about evaluating text attentions, let's go right to the discussion. And I say attention is undoubtedly useful as a building block in neural networks, but their interpretation as attribution is disputed. And I say due to the lack of ground truth information on word prediction correlation, yes, the fundamental correctness of such proxy metric is unclear. And we find, and this is MIT and Microsoft, we find that attentions can hardly be interpreted as attribution for model understanding and debugging processes. So as you can see, let's say, this paper presents that the experts in end of 2021 say maybe there's quite a lot of work to be done to improve feature attributions. And I think this is interesting that YouTube gives us this as the third of our top 3 videos. So we have a real nice summary here where I would recommend watching the first, really the top 1 video YouTube recommends to us. This is really a great video if you want to have a lecture from a university, of course, Stanford. Beautiful code, clearly mathematical code implementation in PyTorch, in TensorFlow, citing the original mathematical equations very beautifully, very nicely done. And then for the 2022 perspective, do feature attribution, correctly attribute feature, a very, I wouldn't call it critical, but indicating that a lot of work has yet to be done to have an absolutely reliable feature attribution in vision, text, and other logical explanation for deep learning networks. This is it. I hope it was informative for you. I learned quite a lot, and I must say I'm impressed with the YouTube algorithm providing us this information. If you want, put in feature attribution in your search parameter field. Have a look what YouTube presents to you based on your viewing history. You will get a complete different list. But I have to say, in my case, this is interesting. I will have a look at quite some other papers here. For example, PayPal, what PayPal does with Shapley values in game theory, but also some paper I found here from medical point of view, medical imaging tutorial, incorrect feature attribution, because you also learn from mistakes. This was it for this video. I hope you enjoyed it. You learned a little bit. And please, if you have a video where you say, hey, I found the perfect video on YouTube for feature attribution, send me a link in the comments. We'll send everybody a link and show what is your preferred video for feature attribution for explainable, interpretable AI. Thank you, and I'll see you in the next video.